In this last session on techniques of differentiation, we'll do some examples just of a variety of kinds of problems. So first, example A, we need to find an equation of a tangent line to the graph of f at a point, and then use our calculator to confirm the results. So we'll do example A, y equals x squared minus 4x plus 2 times 4x minus 1, and we'd like to find the equation of the tangent line to this curve at the point 1, negative 3. So if I know the slope or the derivative at that point, then I can come up with the tangent line. So first let me find y prime. I'll need to use the product rule. So the product rule is the derivative of the first function, in this case 2x minus 4, times the second function, in this case 4x minus 1, plus the first function, in this case x squared minus 4x plus 2, times the derivative of the second function, in this case 4. So this is an expression of the derivative. I want to know what is the slope of the tangent line at x equals 1. So I'm going to substitute 1 in for x. When I do that, I end up with negative 2 times 3 plus, negative 1 times 4. And simplifying this a bit, we get negative 6 minus 4, which is negative 10. So the value of the derivative at x equals 1 of our original equation is negative 10, and that is the slope of the tangent line there. So given our point 1, negative 3, this means that the equation of the tangent line must be y plus 3 equals negative 10 times x minus 1. And again, I'm just using point slope form, right? Y minus y1 equals m times x minus x1. This is the equation. There's no reason to change it to slope-intercept form, even if you want to. Now, if I was going to confirm the results on my calculator, I might confirm the derivative by using n derive. And for y1, I'll put my original function, which would be x squared minus 4x plus 2 times 4x minus 1, comma x. So I want the derivative of my function with respect to x at, I'm going to put at the point 1 and hit enter. When I do that, I get negative 10, which confirms the slope. The second thing that I could do to confirm this is to graph both of these things and just look to see, do they look like they are tangent. So let's do that. So I've typed both functions into y1 and y2 respectively. Notice that for y2 I had to subtract 3 from both sides to get it equal to y, just so it was in function form. And when I graph these, I can see here is the curve, and here is the tangent line, so I'm content with that approximation. Now, if we move on, determine the points at which the graph of the following function has a horizontal tangent. Well, to find a horizontal tangent, what I want to know is all horizontal lines have a slope of 0. So I want to know, when is the derivative equal to 0? Whenever the derivative is equal to 0, that's when I should have a horizontal tangent. So let's consider example B. Y equals x squared minus 3 over x squared plus 1. Well, to take the derivative of this, it's a quotient, so the derivative of the numerator, 2x, times the denominator, x squared plus 1, minus the numerator, x squared minus 3, times the derivative of the denominator, in this case 2x, all over x squared plus 1 squared. And I want to know, when does this equal 0? Well, it will only equal 0 whenever the numerator equals 0. So I want to know, when is 2x times x squared plus 1, so I'm going to clean this up, 2x cubed plus 2x minus 2x cubed plus 6x. When is this equal to 0? Well, it equals 0 when 8x equals 0, which is when x equals 0. So this is the x value at which there is a horizontal tangent. Now, since the directions are determined the points, I need to go back to my original function to find the point. And when I plug 0 into that, I'll have 0 squared minus 3 over 0 squared plus 1, which is negative 3. So there's a horizontal tangent at 0, negative 3. Next kind of question is a chart question. And so if we consider this chart, we might look at things like, we're told a bunch of information in that table, and we want to know what is something about f. So we're told that f of x equals 4 times g of x minus 1/2 h of x plus 1. We want to know something about the derivative of f, specifically what's going on at 3. So first, let's find f prime of x. Well, that must equal 4 times the derivative of g, which would be g prime of x, minus 1/2 times h prime of x, plus 0, because the derivative of the constant is 1. We're being specifically asked about f prime of 3, which would be 4 times g prime of 3, minus half of h prime of 3. And in our table, we're told that g prime of 3 is negative 2, and 4 times negative 2 is negative 8, and we're told that h prime of 3 is pi. So this ends up being negative 8 minus pi halves. Finally, let's just briefly describe some notation. We can continue taking the derivatives until we get to 0. And then we just keep getting 0 over and over and over again. So some function, y, can be equal to f of x. And the first derivative is said to be f prime of x. And the second derivative is said to be f double prime of x. And the third derivative, because we don't want to put so many primes, might be f third derivative of x, fourth derivative of x, so on and so forth. Right, so that's just relating to the derivative. We could also talk about this in terms of y prime, y double prime, y triple prime, or we could have the derivative, we could take the derivative of y, and this ends up being dy dx. And we might want to take the derivative of dy dx. And so our notation will become d2y, the second derivative of y, with respect to x twice. And we might want to keep going and take the derivative again, or get the third derivative. What's the derivative of d2y over dx2? Well, notation-wise, this just becomes the third derivative, d3y over dx3. So there are multiple ways to use the notation for third derivative. Here would be one. Another one would be y triple prime, depending on the context. Another one might be f of 3 of x, third derivative of f. They all mean the same thing. Let's look at example A and find the second derivative. Right? The second derivative is just the derivative of the first derivative. So if f of x equals 8/3 x cubed minus 5x squared minus 7x minus 1, then the first derivative, f prime of x, will equal 8x squared minus 10x